Kepler's laws of planetary motion. In astronomy, Kepler's laws of planetary motion give good approximations for the orbits of planets around the Sun. They were published by Johannes Kepler from 1608 to 1621 in three works: Astronomia Nova, Harmonite Mundi, and Epitome Astronomiae Copernicanae. The laws were based on Kepler's concept of solar fibrils, adapted to the accurate astronomical data of Tycho Brahe. These laws replaced the circular orbits and epicycles of Copernicus's heliostatic model of the planets with a heliocentric model that described elliptical orbits with planetary velocities that vary accordingly. The three laws state that 1. The orbit of a planet is an ellipse with the Sun at one of the two foci. 2. A line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. 3. The square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of its orbit. The elliptical orbits of planets were indicated by calculations of the orbit of Mars. From this, Kepler inferred that other bodies in the solar system, including those farther away from the Sun, also have elliptical orbits. The second law establishes that when a planet is closer to the Sun, it travels faster. The third law expresses that the farther a planet is from the Sun, the longer its orbital period. Johannes Kepler's laws improve the model of Copernicus. According to Copernicus, 1. The planetary orbit is a circle with epicycles. 2. The Sun is approximately at the center of the orbit. 3. The speed of the planet in the main orbit is constant. Despite being correct in saying that the planets revolved around the Sun, Copernicus was incorrect in defining their orbits, introducing physical explanations for movement in space. Beyond just geometry, Kepler correctly defined the orbit of planets as follows. The planetary orbit is not a circle with epicycles, but an ellipse. 2. The Sun is not at the center, but at a focal point of the elliptical orbit. Neither the linear speed nor the angular speed of the planet in the orbit is constant, but the area speed, closely linked historically with the concept of angular momentum, is constant. The eccentricity of the orbit of the Earth makes the time from the March equinox to the September equinox, around 186 days, unequal to the time from the September equinox to the March equinox, around 179 days. A diameter would cut the orbit into equal parts, but the plane through the Sun, parallel to the equator of the Earth, cuts the orbit into two parts with areas in a 186 to 179 ratio. The areas swept out in an ellipse will differ by twice the area of a triangle, with the focus and the two minor axis points as vertices.